All right, so this is a linear gradient problem from your textbook, Park, Chapter 3, Problem 3.38. And it illustrates a few interesting points, so I thought I would do this one for you. Obviously, I can do others, especially if you ask. So an individual deposits an annual bonus into a savings account that pays 6% interest compounded annually. And the initial bonus is $20,000 and increases by $5,000 each year. How much will be in the account immediately after the fifth deposit? So that's asking for a future value. So we're looking for the future value of this series. The other thing to say is you will immediately note that this is a linear gradient problem because the amount by which the series increases is denominated in dollars rather than percentages. And we know several things, and I think one of the first things to do maybe is to draw the cash flow diagram. So I'm going to grab a ruler here to make it look tidy. So we'll have the initial one, and then we'll just break it up into a uniform series and a strict linear gradient series so we can see what's going on. So for the total, this is time 0. So we're asking about year 5. There is an initial deposit of $20,000 that goes in at point 1, year 1. So here's our $20,000. And then every year thereafter, you add $5,000. So this one's going to be $25,000. And then this one, I'm running out of room. I think you get the idea. This one's going to be $30,000. And then, of course, this one will be $35,000. And in year 5, the bonus will be $40,000. And maybe let's just stop and think about what type of problem is this? Well, this might be the type of problem where you have a great job and you'd love to save up for a house, and you feel like, oh, I don't want to use my regular salary, but I do get a bonus and I know it's going to go up every year. So you're thinking, how much money would I have if I kept my bonus in a savings account for 5 years? Would I have enough for the down payment on a house? So it's actually a fairly common problem that people might run into. What if I set a certain amount of money aside each year, knowing that it's going to increase? And then how much would I have saved for my dream vacation or the down payment on my first house or something like that? So we can break this series down. I know I only showed it partially, but we can break that down into 2 parts. We're going to have a part that is a uniform series. And for the uniform series, we have a payment of $20,000. So it's always $20,000. And then we have a strict linear gradient series. And let me get the years in, because I want to get this right. Okay, so the initial deposit was $20,000. And then after that, so if we start at 0, there was nothing in the strict linear gradient series at that point. So beyond that point, though, every year you get an extra $5,000. And we'll get the last one in. So in year 5, you would add $20,000 to that initial $20,000 bonus to get the full amount of the bonus. And then the question says, what's the future value? So we'll start with the easy thing, which is we want to find the future value of the uniform series, and then we're going to add it all up. Okay, so F is equal to A. That's the uniform amount of $20,000 with the factor F of A given I, which is 6% in this case, and N, we want to know how much this stream of income is worth in just immediately after the 5th deposit. And they say immediately after because they want you to know that there isn't time for that deposit to earn money and any interest. So that's why they're sort of telling you that. So A is 20,000, and I've looked up this factor ahead of time. It's 5.6371. And if you multiply 20,000 by 5.6371, you should come up with $112,742. Okay, so that's the first part of our problem. This series is going to be worth $112,742 just after the 5th deposit's gone in. Now we want to find the future value of the strict linear gradient series. And you go, okay, I'm going to go over to my trusty tables and look up that factor. And then you would say, oh no, they don't have that factor. So you have to get at it a little bit in an indirect way. So if we look at what's available to us in terms of factors for the linear gradient series, we have access to one that could tell us what a uniform payment, so it could tell us what the equivalent A was, a uniform payment. And then alternatively, we do have access to a factor that will tell us what the present value of that linear gradient series. So we're going to add this guy here. So we're going to have to be a little bit indirect about finding the future value of that. So you've got two ways to do that, and I'm going to do it one way, but if you did it the other way, that's great. So step one, I'm going to find the present value because I have a factor that lets me do that. And so that would be P is equal to G multiplied by this factor. So we got, again, 6% and 5. And this gives us $5,000 multiplied by 7.9345. But now I know what P is, and I want to know what F is. So if I did this by itself, I found a single value in the present. So I'm going to go back to my factor tables and find this factor. So if I want to know, if I want to know what something's worth in the future, then I should use F given P. So I can multiply what I have so far by F given P, which is a single payment factor. And that, if you look that up for 6% and year 5, is 1.3382. All right, so first of all, I took my strict linear gradient series and I brought it all into the present. So I now know the present single payment present value of my series. And then I use my compound factor in order to find out what it's worth in 5 years. And when I do that, you should come up with about, and it varies depending on your factor tables, because remember I talked about rounding before, but you should come up with about $53,090. And then all that remains is we've got sort of part A here. We found the uniform series, and then we've got part B. And so to get the answer, we have to add A and B. And when you do that, you should get, let's see, 165,000. I got to get my calculator. Actually, I didn't do that one. Let's see, what do I have? $165,832, or thereabouts, depending on exactly what your factor tables look like. Okay, so that illustrated quite a lot of things that we need to know. That getting a future value of a linear gradient series is easy. We just have to find either A or P, and then we can use the compound amount factor f of P to project that into the future. But if you were saving for a house only using your generous annual bonus from this particular example, then you would have a tidy sum of money at the end of after you've made your 5th deposit. All right, that concludes this particular slide.